Welcome to a new test and teardown video. This time it's another Tektronix. And this time it's called a Type 526 Vectorscope. I believe my unit here is from about 1966. I saw some stickers inside. Some notes about 66, so that sounds pretty fair. This one is 19.2 kilograms, so it's quite heavy. As you can probably see here, it's full of tubes. So this thing is completely tube-based. I mean, it's just full of tubes. I did a little rough count, and I think I can see about 50 tubes. I will, of course, do a little bit double check, super count when it's more open, but it is in about that range. So I expect this thing will use a few hundred watts of power. I also see a very big fan at the back. This one is, yes, I said a Vectorscope. So this means it's for television studios or something like that. It's somebody who's creating a color TV signal. The original design was only made for NTSC, but since this one is with a the label on the back says it's for 234 volts of mains, and also I see the frequency here, 4.43 megahertz. So I just think this one is adjusted for PAL TV systems. And I also see that I think I have a missing plastic plate here on the front with all the different faces and all the different colors marked on the screen. I was told this screen should be blue phosphor, but that is, of course, not the case. These should be green phosphor. You see here at the front we got no input connectors, and that is, of course, because this is for a permanent installation in a TV station, so all the connectors, they will be at the back. The first little idea I got when I saw this is maybe we have a something missing here to protect this hole, but that is not the case. I googled a little bit around, and other pictures, actually all the pictures I've been able to see, is looking exactly like this. So that's just how it is. It's using PL259 connectors for every input we got. Got internal or external. This switch here is broken, so there's definitely something here. And to be able to see, to detect all the different phases, of course, we need to have a synchronization signal. Subcarrier input, and we've got A and B inputs. I believe that will be a composite video signal. And what happened? Oh, that is loop through inputs. Okay. And a very big fan indeed. I will go around and do a little visual inspection. What I'm looking for is lead capacitors or anything like that that should tell me not to power this up before this has been fixed. You can see, of course, this is really old technology. We got no circuit boards. It's all point-to-point technology. This is how this is designed. It was initially made in 1959, but I think this one is from 1966. So of course, once they invented this, they just produced this for many years. You see this ceramic here. This is some special silver alloy on this special kind of ceramic substrate. So you cannot use normal solder on these because it will create a a barrier, a chemical barrier that will break down these and they will fall apart and stuff like that. So you need to use the right solder, and here is the correct silver solder for any kind of modifications. It's always located inside those units, so that is pretty neat. So I got the idea I could easily lift this up because it should be hinged, but I cannot do that. I think something in here prevents me from doing that. How annoying. So I was able to lift this unit, and the problem is the plastic covers for the capacitors. This one is loose, so it falls down, and then it goes in here and interlocks. So I had to stick in a screwdriver via this hole, grab down there, and then pull it up. But now it's here, and you can really see how many tubes we got in this unit. And I think this explains a little bit about the fan blowing the air around in here. So here is the crystal, the 4.43 megahertz or whatever it is. This is of course for PAL. It will be 3.5 megahertz or something like that for NTSC. So I think this one is for PAL. Here we got another socket. This is for another type of crystals in tube sockets. And they were quite normal back in the 60s. But the more modern crystals, they look of course like that. I did a little, see here, that will be my little indication for how many tubes we have in each row. Where are they hidden and all that. So I did a little bit of calculation, and I also, found another one hidden down there in the darkness. Where are you? I don't know if you can see, but there is one more tube. Yes, here we go. So we got 53 tubes in this unit, and I count of course also the CRT as a tube, and I also count voltage regulators. Anything that looks like this, I mean, that is a tube, right? I went through all of them and just did a little bit massage to all the sockets. Maybe I forgot that one, because that is the sound you hear when they have not been moving. So far I found, of course, this broken switch, but I also found the fan. See? It is not so good, so I will try and give this a little drop of oil and see if I can get this spinning. What else did I find? Look at that. It is here. And this is what I was looking for. So this dark plastic here at the front and no light from the back, completely sealed, made it impossible for me to see the printing here. And this is where you have all the different colors in your colorbar system. So you should see this, and of course if it's perfect, what we're gonna see is we're going to see it hits exactly those spots. And now I can go and clean this one. Yike. And there's of course a little dark spot in the middle. That is typical when there's no modulation. When you have a dark TV picture, then you go to the middle. Normally those scopes here, a Vectorscope, they should have a input signal level detector. So when there's not that much signal, it should dim the beam, so you have very little brightness when there's just a dot in the middle. But it seems like this system is not working perfect for this system, or somebody just cranked up the illumination here, so that's probably what happened. So just a little drop of oil, and look at that. Now the fan spins, and now I can assemble all this again. Can you imagine how many hours it takes to do all the soldering here. And it's done in layers. I mean, you can obviously imagine all the stuff goes to the sockets needs to be done first. And then you take all those connections up and then you add another layer. And you end with all the big components that's sticking up here and all that. So it's just, I'm very impressed about this building technique. And it sounds like it's very, very expensive to do. Here is the high voltage power supply for the CRT, obviously. And it takes 500 volts input. And you use all those tubes in this area here. So it's a regulated negative supply for the cathode system. So the cathode system is running about 3,000 to 4,000 negative. And they try to add a little bit of isolation here. This is of course the diode that creates all this, rectify this high voltage. I don't know if you can see what happened here. Can you see the little funny thing here? I need to clean this, of course, but this is because of the high voltage. And you don't want this leak to intensity and focus knobs. So I will have to clean this a little bit. Also, this I don't like. Corrosion here. I think I'll clean all this up a little bit. So I didn't find any leaked capacitors or anything preventing me from powering this up. So I think I'm gonna go for it. So here's another one of those mixer oscillators. And this one is also running at 4.4 megahertz. Down here you see, I don't know if you can see this, but there's a socket down there, the little brown one, and that is a transistor. There is one transistor in this unit. Amazing. And that will be the stickers or the signature here. See, 66. And it's also written here somewhere here, inspected in 66. So yeah, I think this one was done in 1966. See? If we look real careful here on my screen, you cannot see any of the gratings or anything like that here on my unit. I've been Googling a little bit around and I find some pictures online that clearly show it looks a lot different. So maybe the different types of plastic layers here in my unit should be flipped around. So maybe this one is assembled wrong, and that is why I can't see this. And I've been consulting the manual a little bit, and it's revealing that this unit should use about 340 watts. So that is quite a lot, and I think I am ready to do the first power up. I don't have any signals connected to it, so I expect to monitor all the tubes. I don't see any white topped tubes, so I believe we got vacuum in all of them, but that is not the same as anything is working or not. And then I expect to find a dot in the middle in the phase display mode. Otherwise we can also go to the horizontal sweep, but you probably need a tricked signal to do that. So let's try and do the first power on. I will of course turn on the unit here on the front. I put all the dials in the middle and then we'll see what happens. And then I just slowly see while monitoring. Now the fan starts to move. That is exactly what I want. See, power consumption here is not bad at all. I think I can easily just crank it all the way up. So 320 watts, and now it goes a little bit down. It's about 300 now, and let's dial on the intensity here. Nope. Of course I should. What have I done? Test circle. Of course the balance, it could be out of the screen, but at least nothing is... Nope, nothing is smelly. I would have loved to see a little dot on the screen. Well, I will go and check all the tubes, and now I'll go and check all the voltages. I found a very good manual for this thing, and it says exactly what to check for, but at least it's using nominal power consumption, so I think it's not that bad. Not a bad start. I went by the troubleshooting guide, and line number 4 says check the cathode supply should be negative 3800, and it is actually positive 77 volts. So first problem found, and the first 3 steps, the other 3 voltages, they are nice and fine and stable and regulate and do all things right. So it is in the high voltage section. Here is what we have established. We have no negative high voltage. Those 2 neon bulbs, they are not lit. And there is this V800 that is doing all the high voltage chubby thingy. That is the left tube there. And ice cold tube. I don't know, it's difficult to show. Yeah, here we go. That one is ice cold. There's one to the left of that one. So we found a dead tube. Here is my tube. I think it is running absolutely ice cold. And you know what? I don't know if you can see this. See? Filament works, and just by applying the 6.3 volts, it's supposed to use about 0.9 amps. So this is very, very close to specifications. I only look at the filament, you know. I mean, it gets nice and warm. So what is happening here? Why is it not working in my unit here? Have we got some missing filament? But why have we got filament on all the other tubes? I think we should have a little look at the schematic. I got some kind of a major breakthrough, because I did, of course, verify that tube is not defect. It was the socket or the pins here. So what I did is I took the 2 pins here for filament and I wiggled them a little bit. So now it's actually working. And I got my regulated high voltage, and let's try and crank this baby up, and I will show you what is going on. It's upside down, that don't work. So this is a little bit better, right? Isn't that just beautiful? And we can position. Ooh, that will be the 2 phases. We can make a little circle here. Test circle amplitude. Wow, how nice. So I believe that was all I had to do. What do you think about that? So here it is, this Q40 transistor, and it is of course one of the crystal oscillator that is going to be used for mixing the incoming video signals to another oscillator, and this way create the different phases. I think it's really funny to see that this is the one and only transistor you will find in this unit. It's also really weird. Why are you using only one tiny little transistor to do this oscillator, and the rest of the unit is just full of tubes, and each tube is using 2 to 4 watts of power, and this one is just using a few milliwatts. We got like this unit, the total unit here could have been using 30 watts instead of 300. I think I forgot to show and tell a little bit more about what all these things are doing here. So I think you can see we got some capacitors and inductors like that. Obviously what we have here is a delay line, and you can select the wanted delay you want. And this is for the external synchronization. It can do two things. It can sync to an incoming video signal, or it can have an external sync. And of course, if this the cable is longer or shorter, or they're not in perfect timing, then the phase demodulation of the different points and the different phases will give you the different colors. They will be twisted to the wrong phase, and that is exactly what twists the picture around. That's the phasing. So what you do is, obviously, you give it a colorbar signal, and then you adjust the correct delay or the phase until your dots on the screen is correct. So then when you have almost the right range, and I think this is really cool, you have 0 and 330 degrees, and then you have no indications of all the minor steps here, and that's because it's really not important. You just pick one. I'm sort of there, right? And then I select internal or external. Of course, the free running oscillator is here. Oh, let me get some light here. Burst controlled oscillator that is controlled by this burst. Then you can fine tune your phase right there, and then you can go into precision phase for fine, and then you lock it, and then you have your picture nice and steady on the screen. So let's try with a little video signal. So we just picked up a nice little color pattern generator. This one can do color bars, and this is exactly what we need for this system to work. So that you see here is actually the color burst signal, and that will be the color bars. So it seems to be that it triggers on the entire picture here, and then you can go down there and zoom it into the start, and you can go into the Vectorscope mode like this, and we can adjust it. See, it should be adjusted so it's round, and then you should of course adjust this is the signal level here, and as you can as you can see, we have no lock. So that's either some of the oscillators that are not gripping. I try to. This should not work because I don't have any external subcarrier. I'm using see? So the idea is it moves to the left or to the right, and then you can move this one here. See? Now it goes too fast this way, and then you go that way. Then you should have a lock, and then you'll get all the different colors at the right place. Oh yeah, you see here? This one is not having a contact. If only I can make this. Yeah, that is difficult, and I think it's impossible to go inside this unit. This is a coaxial delay line, so it's very, very special, just like a multi-turn resistor potentiometer, but this one is a coaxial line where you can adjust the delay instead of the resistance ratio. And this is exactly what I wanted to show you. Now I'm using external subcarrier input, so that works. There's a problem with obtaining subcarrier from a composite video, but it can of course use an external subcarrier input, and what do you know? It works, and you can see here you can adjust the phasing and all that. So the idea is that each of the colors in the subbar, in the colors they are here, right? You can see they should be here, all of them, and look at that, it's all there. See, I can even adjust the. Yeah. Here we go, man. And now you can input all sorts of other video signals, because now it is correctly adjusted. Let's see how it works with something. Oh, that's of course. Oh yeah, okay. They got no colors, so it just spins around like that. Oh, I can make it do all sorts of funky. Oh, so that is the picture with and without the color bars. So that is all I wanted to show you in this video. So thank you very much for watching, and I hope to see you soon again. Bye bye.